Everybody, I could have written this problem in this form, there exists a K. You know, we have the universal quantifier up here for all in. Here, there exists a K. All right, I would have to word it slightly differently, but what I'm trying to convey here is any integer that's in this form 3n plus 2 is going to have a divisor of that same form, 3k plus 2 for some other k. Now, here's a concrete example. 497 is equal to 3 times 165 plus 2. Notice that 71 is equal to 3 times 23 plus 2. Okay, 3 times 23 is 69 plus 2 is equal to 71, right? 7's not in that form. But anyway, for this problem that was in the form 3k plus 2, we wrote a factorization where one of the factors, or one of the divisors, was of the form 3k plus 2. All right. Now we want to show it in general. Now the simplest case is if a number, this number can be prime. For example, 17 would be in the form 3 times 5 plus 2. So you're done if it's prime because any number is a divisor of itself. We would just take k to equal to n. So case 1's trivial. I'll say that without the slightest sense of pretension. Now right here, case 2 is if 3n plus 2 is composite. Now what that really means is 3n plus 2. And you probably don't really need to write this down, but just to be sure, if 3n plus 2 is composite, that means it has a pair of divisors that are strictly between 1 and 3n plus 2. That is, okay, we have that going on, and also, and I don't think it really came into play in this problem, but the definition of composite means that 1 is strictly less than m. Y'all, let me get this. I'm going to run out of room here. 3k plus 2. See, it has two divisors between 1 and the number itself. So I'm going to write this here, folks, less than 3n plus 2. I knew I would run out of room there. Okay, folks, and again, this is the definition of what we mean by composite. You have two divisors strictly between 1 and less than the number itself, such that their product is such that 3n plus 2 is equal to m times 3k plus 2 in this case. All right, this is saying 3k plus 2 is a divisor. Now we're going to try to carry on in a contradiction sort of way. Now, I'm not going to rewrite the 4n and there exists k and all that. I'm just going to, that's kind of understood from the beginning that this is a universal quantifier and this is an existential quantifier right here. So we're going to make the assumption that this is never true, right? For all n and there's not a m that satisfies this condition. All right, now, if two numbers are not equal, then also they're not congruent. That's a big deal. And also we can exploit the fact, modulo 3, that 3 is congruent to 0. Okay, 3 is congruent to 0 mod 3. Okay, so you see how this 3 goes away and this just craps out to be 2m right here. Okay, kind of nice. All right, but now let's go back to the world of equalities. This says that 3n plus 2 is not equal to 2m. And I'll write this just for all n. Right? This is where writing down the universal quantifier is very important. Notice this is completely false if n is even. If n is even, this left-hand side is even, right? And you would get 3n plus 2, right? It is an even number, which would contradict this, right? So again, this is what this contradiction, this is what this statement means. it means that 3n plus 2 is never an even number, but I just told you that if you take n to be any number, any even number, 3n plus 2 is an even number. 3 times an even number plus 2 is again an even number. Okay? This is supposed to read 3n plus 2 is even. Okay? So that's a contradiction, and that means that we know that 3n, since we contradicted this statement right here, that means that 3n plus 2 must equal. A lot of people don't like these contradiction proofs. I didn't see another way to do this. Uh, 3k plus 2, sorry, 3k plus 2 for some k. All right, folks. So that's the proof. Hope that made sense. Let me know if it didn't. Let me know if you think I did it wrong. I think it's a good proof. You're just doing some modular arithmetic. So this says that 3n plus 2 can be represented as m times 3k plus 2, meaning that 3k plus 2, that's a little sloppy there, 3k plus 2 is a divisor. Okay. That's it. Thanks for being.